Introduction slide on?
It's 11 o'clock.
It is 11 o'clock.
Yes, welcome to Alabama Astrobotics
You
Space
have to
Days.
enunciate more, probably, Greg.
Welcome to Alabama Astrobotics Space Days virtual booth.
Please bear with us today, as we've never done this before, so this is a new experience for all of us.
So we have a QR code up there, just asking for some information. If you'd like to get in contact with us, you can put that in there, and we will send you an email later on.
We also would love for you to fill out this poll so we can get a sense of how many people we're reaching today. That's an important part for our outreach paper. We like to keep track of how many people we're reaching out to.
So I will leave this on screen for a little bit, and we will come back to it later as well.
Yeah, I think we can just leave it on screen and start to talk about the team a little bit. We are Alabama Astrobotics. We're a student design team here on the University of Alabama's campus. You can see we're sitting right now in our lab, and we build robots. Every year we compete in NASA's robotic mining competition, which is a competition that's designed as an analog for lunar mining. So under the surface of the moon, there is icy regolith, which is kind of an icy, rocky substance. And obviously we need water when we're on the moon because we have humans to sustain. We have rocket fuel to make. We have oxygen to make. Water gets you all of those things. So we want to excavate as much of it as possible from under the ground. And that's what our competition's all about. So we build an ice mining robot every year. Yeah.
Do you want to show them our nice boxes of our simulants?
Yes. Might need to get closer to the camera.
Yep. So in the, let's see, we'll have to get a little closer. So in the NASA competition, we have to operate in a pit much like the one that Austin, you probably can't really see very well behind us, but it's there. It's a pit full of, in NASA's case, 12 inches of this stuff named BP1. It's a crushed up volcanic rock from somewhere in the western US, I don't remember what state. But basically NASA determined that's the closest thing that they could find to the surface layer on the moon and also Mars. Kind of toxic stuff, to be honest. You have to be careful around it.
It's basically crushed volcanic rock.
Yeah, which is why our pit is full of crushed up limestone instead. Fair bit less toxic, but it acts more or less the same. But in either case, underneath that is a several inches deep layer of gravel, which is the simulant for the ice that NASA expects to find on Mars or the moon. So our robot has to be able to dig through the layer of BP1 or limestone, several 12 or more inches down to get to the gravel underneath, pull it up, and deliver it to a collection container.
So basically, the reason we use limestone here is because in Alabama, it's much easier to get the 22 tons of limestone that's currently sitting in the pit behind us. And also, NASA has the only access to BP1 because it's extremely expensive because it's volcanic rock, which is quite rare.
Yes, NASA has access to the only quarry of BP1, so luckily crushed limestone is very easy to find in Alabama, so that is our substitute. It acts very much the same. So we have to dig through an entire foot of compacted crushed limestone to get to the gravel beneath, which, as you can imagine, is quite a task. So let's talk a little bit about our team, the subsystems that we have, and what each of them do.
All right. First up, we have the mechanical team. They designed the robot to meet all of the physical requirements, such as the size constraints, being able to reach down far enough to pick up the gravel, and being able to offload what we do pick up into the collector sieve at the end. This is quite a complicated task, specifically this year, as the size constraints for the robot are very small, yet we still have to dig down 16 inches?
Yes.
16 inches. The next subsystem is electrical. They are responsible for supplying power to the robot and all of its logical systems and moving all of the components. They act as an interface between mechanical and our third subsystem, which is software, who is responsible for writing all of the software for the robot to allow it to operate. We also, in addition to just driving the robot around, have made it fully autonomous, which we are one of only 2 teams in the last competition to have accomplished. So we're very proud of that.
Autonomy is really important in this application. It's very difficult to physically control a robot that's operating on the moon for several reasons. One, if you do it from Earth, you have a bit of an information delay, a time delay for the communication. And 2, if you do it from the moon, astronaut time is really expensive. So it's best if these can remain fully autonomous.
The basic math there with the, even when you're on the moon, is as the as the astronaut is using the robot, they're using up oxygen. And so every piece of ice the robot digs while the astronaut is operating it, you're losing a bit of that because you've got to make more oxygen of what you just lost. So making it fully autonomous saves everyone a lot of hassle and a lot of time in the long run.
And also, at the current moment, just simply launching astronauts into space is very, very expensive. So until we get a little bit more of a reliable human transport system, we're going to need autonomous robots.
What's the price for enough water for 1 human to survive on the moon for 1 day?
I don't know, but it does cost roughly $1 million to send 1 kilogram of mass into space.
Gosh, that's a lot.
It's expensive.
Expensive.
Which is one of the reasons why our robot is actually limited by mass as well as size. The approximate launch volume of the average space payload, according to NASA, is approximately the size of our robot. So we are only allowed about 0.5 meter by 0.5 meter by 1 meter of space and only 60 kilograms of mass.
That's small.
Yeah.
It is small.
And when you really think about that, like that's about 19 inches tall the robot is allowed to be, and to successfully mine a decent amount of gravel, it has to be able to dig about 16 inches down. So you pretty much have to be able to dig most of your own height down beneath your height. So it's quite an interesting challenge.
Yes. So we actually have a question from the chat. Julia asks, isn't it kind of boring doing the same project every year?
No, it is not. So NASA actually has changed the rules over the 11 years the competition has been running. When it originally started out, the goal of the challenge was to only mine the surface layer of BP1. Later on, they changed the challenge to also include the gravel underneath, and even more recently, they removed any points that you get from mining the surface layer of BP1, and now you only get points for mining the lower layer of gravel. Furthermore, NASA has just recently built a new indoor arena, whereas the competition used to be held outdoors. This arena is smaller than the old one used to be, and to accommodate this, along with what NASA sees as their goal for actual mass and size constraints, they have reduced those significantly from the last time the competition was run.
So, Ben, what is the main reason that we think NASA got rid of the ability to score points off of mining up BP1?
So, our team has historically been extraordinarily successful in this competition. And so, as we progress and more successfully mine, NASA is increasing the level of difficulty for this challenge as per with their goal to keep the competition relevant and interesting.
What Ben is trying to humbly say is that we got too good, and so they had to make it harder.
Yeah,
Was
yeah.
it 300 kilograms of BP1?
Something like that.
I thought it was 130 kilograms in the final year before they changed the rules.
It was a very large amount of BP1, and NASA was like, well, you
Well,
guys have kind of broken it.
We know how to do this now.
The short answer, we solved the problem. So the problem had to evolve.
They had to make a new problem.
Yes.
So we have won the competition 6 times total, and that is the last 5 times in a row. And we would have, I can't say we would have won last year, but I think we would have won last year if the competition hadn't been canceled because of obvious reasons.
Yes.
So,
Unfortunately, the last 2 competitions have actually been canceled. The year before last year, which is 2019. Is that right?
Yeah.
Yes.
it was the 2019 competition.
Yes.
Yes.
The 2019 competition was unfortunately canceled due to logistical reasons, and this year the 2020 competition was canceled due to pandemic reasons. So unfortunately, we haven't been able to compete in a while, but we are still working hard. We're building robots. We're doing everything we can do.
Yeah, and the first year when the competition got canceled, we partnered up with Caterpillar and hosted a version of it here. We didn't host it. Caterpillar hosted it.
And the university offered our facilities.
Yes, because we still wanted to compete, and we competed in that competition. And we won that competition as well.
Yes.
So it's like we've won 7 times.
Greg, do you want to show the competition video?
I will show it after we show the quick picture.
One thing I'd like to mention first is that our faculty advisor, Dr. Ricks, has corrected us, and that following year before NASA said that the fluffy Regulus was worth nothing. The first competition run was 163 kilograms of it, and the second run was 173, which is a record in the competition by quite a long shot.
So it was a total of over 300.
Yes. And to give you some perspective for that, each one of those runs was only 10 minutes long.
So for a total of 20 minutes, we got over 300 kilograms of BP1, which is a lot
Yes.
compared to most teams which don't get much at all. So this is from,
So these are some pictures from that robot we mentioned 2 years ago that actually have to compete here at our own facilities in the Caterpillar competition. This is the robot that we lovingly named Bessie. And I guess I could start going over like the general
We have a
web
couple,
operations.
we have a couple questions from the chat
Okay.
first. Do we have a competition next year? Yes, we hope so.
We hope so very much.
NASA has actually restructured the competition this year. It's built in several different phases. So if the actual physical competition is not able to be held, they will judge on the previous phases. So they've built in a contingency plan, and we're hoping that we won't need it.
we're really, really hoping. 3 of us who are sitting here have been on the team now. This is our 3rd year, and we have never seen a competition actually happen in Florida.
We're starting to feel like bad luck charms, but
I'm the lucky one. I got to go to Florida once.
yes. We are indeed tied with the football team for national championships.
Yes,
Yes,
sadly.
yes.
But
That is a good point. We do like to brag about that.
So this is the pictures of that robot, and next slide is the video of the robot.
All right, you want to go over the operations, as I so rudely interrupted you before.
I can, or did you say you were going to do
I can do
this
this.
one? Okay.
So basically, you're about to see our robot run.
Starts video.
Okay, I'll start.
It's 10 minutes long.
That's fair.
It's a while.
It's a long video. So this is
Could be
a
a while.
10-minute competition run. So wait, the robot start. There it goes. So the robot begins by spinning around and using the red and gray beacon you see on the side, or red and gray object you
You
see on
can
the
gesture
side.
with your mouse.
Oh,
Will
can't.
they see it with your mouse?
I do not know. Let me know if you guys can see where I'm gesturing.
I
But this,
can.
perfect. This beacon right here is used to localize using the LiDAR on the back of the robot. It basically tells it, this is where this is, so I know where everything else in the arena should be. It then makes its way across the obstacle zone, which is filled with these rocks, as you can see here, and some craters. We use another LiDAR on the front of that robot to detect those obstacles and attempt to use path planning to avoid them. Now the robot has reached the excavation zone, and it begins lifting the digger head into the optimum angle for digging. Now it begins spinning the teeth forward as a trencher, and it will begin deploying using 2 lead screws into the ground to dig up the top layer. And as you can see, our offloading belt on the back is currently spinning so as to not keep the fluffy stuff on top of the limestone because we don't care about that because it doesn't matter for points. So we just dump that behind us. And then as we start getting to gravel layer, the belt will slow down and eventually stop. And then it will begin shaking back and forth in a way to sieve off any other limestone we pick up.
Yes, our offloading belt is perforated to allow for the soil to pass through when we shake it. I'll say a couple things about our trencher. Our trencher is the best way that we've found to excavate gravel from under the soil. It reduces the digging forces required. If you think about it, overhand is a much more natural digging mechanism. If you think about how a dog digs overhand in the dirt, he doesn't try to scoop up the dirt with his paws, so it's a much more natural digging mechanism, and it allows us to minimize the digging forces.
Like a few years before this, we used pretty much the opposite mechanism, calling it a bucket ladder instead of a trencher, doing the overhand digging instead. And if you go back and watch those videos, you can see that that mechanism would often stall and have to recover from that, losing its time. That's material we can't dig with time we don't have. So we discovered that simply changing the direction increases the performance significantly.
Yes, the bucket ladder was previously the best mechanism for digging up the overburden, the soil that's on top, because it's a lot lighter, a lot fluffier, and a lot easier to pick up. We have a question. What different majors are represented on the team?
A lot of them.
We'll just quickly go over ours. I'm a computer science major.
I'm a computer science and German major.
Computer engineering.
Aerospace engineering. So we have all of these, as well as mechanical engineering, chemical engineering, civil engineering, English. We have a couple business majors on the team. What else? Math majors.
Computer engineering as well as computer science. Electrical engineering.
Basically, every category of engineering that the university offers, we probably have one of them on our team.
Or we have in the past.
Except for maybe metallurgical. I don't think we have metallurgical.
I don't think we currently have a metallurgical.
I think we have in the past, though.
Yes.
Well, I learn new things every day.
So it's definitely not a requirement to be a particular major to be on the team. Like basically, if you're interested, you can be on the team.
Yeah.
So
we have so many different majors, and not all of them are engineering. Like we said, we have a couple business majors who help us out with our more logistical side. We have an English major who helps us with our documentation and our papers. So we really take anybody who's interested in robotics for just the way that the team works.
So this is actually only the first dig dump cycle for the competition run, so I don't want to show the full 10-minute video. But as you can see, there's a lot of rocks over here that we just dumped. And when the robot makes its way back, it uses a similar way of using path planning. I think that year, did it just normally default to taking the way back, or did it try to path plan the way back? It path planned on the way back, I can remember. 2 years ago.
So that load right there, I believe, would be about 16 kilograms of gravel just sitting right there because the entire run was about 33 kilograms.
Yes.
And we completed 2 runs. Well, 2
That's
complete runs.
another record.
Yes.
Not to brag, but
Yes.
But we're bragging.
Right. That was another record-setting amount of gravel at about 30 kilograms of gravel.
Yes.
But yeah. So
How many students are on our team?
On our roster, we have about 68 people. Probably around 50 of those are currently active.
Yes. So we have quite a big team. We have a lot of work to do, so we try to spread it around as much as we can. We have a smaller leadership team of about 8 people who organize everything. We're the leaders, but we try to spread the work around as much as we can since we have such a big team.
I think yes.
Whoa. Okay, so here you'll see a bunch of different ways you can contact us. You can go to our website. You can find us on Facebook or Twitter or Instagram. We have a YouTube page which has all of our competition runs on it. Please, if you want to contact us, do. There's a contacting form on the website, I believe, as well as a couple of emails that would also work.
Dr. Rix's email's on there. I believe our social media leads emails on there. Also, all of our social is listed on our website. So if you go to our website, you'll find everything there.
Yes.
So, yeah.
As well as links to each of the socials, so you don't have to type it in.
Correct.
Yeah. Let's go back to the QR code just in case anybody Oh, Dr. Rich brings up a good point. The trencher consumes significantly less power than the bucket ladder does, which is also a bonus.
A stone motor is pulling a whole lot more power than one that isn't. That's basically, to sum it up right there. If you don't sell the motor, your motor is running a lot cooler, pulling less power.
Points. Like,
Points.
yeah.
So in the competition, power is one of the scoring mechanisms. So the less power you can draw, the higher points you score, which aligns with NASA's goals as if a robot is on the moon or Mars, they need to supply it with enough power to dig, and the less power they have to generate to do that, obviously, the more efficient it will be. It has to spend less time recharging and spend more time digging.
And in all reality, it'll probably be solar power when these robots are actually on the moon. We use lithium batteries, but solar power tends to be a little bit slower with the current technology, so less power, the better. We have another question. What's the approximate breakdown of men versus women on the team? I do not know the actual stats for this, which is unfortunate.
I could go do this math real quick.
Well, we can
I would
also
say
give the admin team.
it's probably about a quarter.
Yeah.
Do you think? A quarter women?
That seems about right.
Yeah.
Yeah.
A quarter to a third, maybe?
Yeah. There's representation on all the subsystems.
Yes. Yeah.
But I don't know the exact breakdown.
Yes.
I'd say quarter.
Our admin team is 25% female, so that is a good representation.
Yeah, that's it for you.
Last year we actually had 50% on the admin team, 50% women. So we're doing everything that we can to get more women on the team. More women interested in STEM is always better. This is also a good representation.
Hey, math tracks.
All right, so just to repeat, this QR code will take you to a poll. We would love for you to fill this out because it gives us some information on how many people we're reaching. Yeah. So you mentioned the power for the points. Do you want to talk a little bit more about how the competition is scored?
Yeah, so the way the competition works is that if you meet all of the mechanical size and mass requirements at an inspection before you run, you are granted 1,000 points. Then your mass and the power consumption, along with how much data you use communicating with your robot throughout the run, are deducted from those 1,000 points. The way you gain points are for every kilogram beyond the first kilogram of gravel that you collect. The first kilogram of gravel that you collect is simply to qualify you for the competition.
So if you don't collect any gravel during one of your competition runs, it just doesn't count.
Right. So you get points for every kilogram of gravel beyond the first kilogram. Then you also gain points for being autonomous. This is structured in a progressive way where if you only do if your robot is only running autonomously while it's in its digging operation and then is manually controlled for its driving, you will get 50 points around there. Then if you can traverse from the starting zone to the mining zone successfully at least once, you get around 150 points. Then if you can complete an entire run there and back, so traversing the obstacle zone, digging autonomously, and offloading autonomously, you get around 300 points. And the top prize for autonomy is if you can complete the entire cycle, which is 2 full autonomous runs, fully autonomously without interruption, and that is around 500 additional points.
So that's obviously always our goal.
Yes.
Our goal is to sit down with the computer, press enter to start the robot, and not touch the computer again. And we usually complete that.
There's also points like I think you start the amount of points and they get deducted for the amount of bandwidth you use.
Yes.
Is that the way that works?
Yes.
So yeah, so obviously if you're having to remotely control your robot entirely, you're going to be constantly in communication with it. That could potentially use up a lot of data, especially on the kind of low speed links that we may have to a robot that's on Mars, for example. So if the robot's autonomous, you also have kind of a natural benefit in that. That also ties into there's cameras that in the competition NASA lets you use. If you don't use those, there's also benefits for that.
Yep. Furthermore, we have found through experience that running the robot autonomously is simply more efficient. That the robot can know how to run itself better than someone sitting in a different room using a mouse and keyboard or a gaming controller to drive the robot. It simply works better.
Especially since in the competition, NASA places a delay in your communications. Because obviously when you're talking from Earth to Mars, there's this thing called the speed of light you have to deal with. So your communications may take, depending on where everything is in their orbits, anywhere from like 15 minutes to 40 minutes to get from one point to another. NASA doesn't make the delay that severe, like I believe in competition it's 2 or 3 seconds, but that's still plenty enough to throw off someone trying to remote control a robot.
Did we talk about max?
Yes.
All right. We have stats from Dr. Ricks. Officially, females make up 21% of the team.
We were close.
So about a quarter, about a fifth.
Yeah.
All right. We have some questions about our outreach. What kind of outreach do we do? So part of the competition is an outreach report. So we want to reach out to the community around us, to the K through 12 community especially, and our goal is to inspire a love of STEM and robotics. So we do a lot of outreach with elementary schoolers, with K through 12 schools, with high school robotics teams. We just want to reach out to our community, help in any way we can. In the past, we've done a lot of projects, like community service projects. We've built cars for children with disabilities so they can drive around. We have built a sensory interaction machine for children with sensory deficiencies. We've done a lot of really cool outreach stuff. Our goal is always just to inspire a passion for STEM.
This year, obviously, with restrictions, we cannot do as much in-person outreach, if any. So most of our outreach this year has been through virtual, and NASA made it a requirement that at least 50% of your outreach must be virtual. So we are doing a lot of that this year. So we are also having to adjust for changes with the world we live in today.
Yeah, so as part of the competition, in addition to the actual physical presence of your robot digging gravel, you get points for, well, outreach, as we're talking about now. NASA is very interested in developing interest in STEM technologies and their future missions to the moon and Mars. Also, we have to document our entire engineering process, and we get assessed on that. This year, more than usual, as the beginning phases of the competition are solely based off of our documentation of where we are in our engineering process. And there's this year there's a gateway where you must pass a review by NASA in those early phases to be allowed to go on and compete physically.
Yes. So systems engineering is a big part of our competition. We write a systems engineering paper, which is about 25 pages long, that documents the entire process. That's due in about April. So we've already started working on that.
Yeah.
We have another question about what kind of non-technical skills we've learned from being on the team.
It's public speaking.
Yes.
Yeah, that's a big thing.
Yeah, before COVID, we used to be in the lab all the time, and we would have tours that would come in because we are on the College of Engineering is very proud of us, so they put us on pretty much the end of their tour. So we used to have maybe 4 or 5 tours every day. If it was a Friday, it would be 5 or 6. And someone would always get up and give what we call the spiel, which is basically what we said at the beginning of this, but in person, showing everything. So yeah, so that definitely became a thing of having to speak to strangers on a regular basis, which is a good skill.
Yes.
And there's also, at least for those of us on the admin team, kind of leadership skills, because a lot of us may know how to actually get this sort of work done to make the robot, but we may not know how to guide others as a community effort to get the project done. So that's something a lot of us have to learn kind of on the job, so to speak.
In your classes, you're focusing on something very narrow, very specific towards your major, and you're more than not working alone or maybe with one partner on a lab. And in this competition, obviously, as we just went through, there are many different majors, there's many different facets to the project, and so you gain a lot of experience knowing how to work in a team and how your contribution fits in with a larger project, and that's extremely valuable.
Yeah, I think that one of the most important things you can learn on this team, or any team like it really, is interdisciplinary communication. In work, always you're going to be dealing with other people, you're going to be communicating with other teams, and that's not something that you learn in class really. So I, as part of the mechanical team, have to communicate with Matt, who's part of the electrical team, and we have to figure out how we can get both of our requirements fulfilled while fulfilling the larger system requirements.
And they throw it at software, they're like, make this move.
Yes.
Yeah, electrical kind of be the intermediary between the two of them, software and mechanical, to be able to fit both of their needs, make sure they communicate with each other to get between the virtual world and the physical world.
Yes. So we learn lots of non-technical skills. Communication and leadership are really important. In my opinion, the only way that you can really learn to be a leader is by doing it. So this is a great opportunity for that. We had another question. What kind of role does a freshman play on the team? I'm a freshman, and to be honest, I don't know much, but I love to learn.
That's it.
Yeah,
It's learning.
That's what you need.
That's what we're all here for.
You need a passion for learning.
I joined this team my freshman year within the first couple weeks, and I knew barely anything about robotics, and I also knew barely anything about programming to begin with, because I was a freshman computer science student. But I started and I began learning, and I spent maybe too much time in the lab, which was our old lab, which was a lot smaller and not as nice as this new
Yeah,
one.
we'll get to that.
So
Yes.
yeah, but yeah, no, it's definitely, this team is what you put into it. You'll get out what you put in. So the more time you give and the more interest you show, the more likely you are to get those skills we talked about out of it and get the meaningful experiences.
If you're someone who already has some of these experiences, like if you did FIRST Robotics, for example, or something like that, that's incredible. Your experience will be very welcome. But if you also don't know this sort of stuff, this is still school. We're all here to learn. That's why we're here.
Yeah.
So if you need to learn this, we'll happily show you along the way.
Yeah, we like to say that all you don't need any prior experience. You don't need any prior knowledge. All you need is a passion for robotics and the time to learn it. So.
Yeah.
That is-
And many times the things you learn here will help you later on in your classes, because a lot of times things that we do, you're not going to do for some weeks or semesters, and that can be super useful. There are programming things I learned here that made it, when I got to them in class, made my life a whole lot easier, and I assume the same is for mechanical and electrical.
Yes,
Yep.
for sure.
Absolutely.
Let's talk a little bit about our new lab.
Mm.
So this lab was outfitted for us in January of 2019 by the college. Very kind of them to donate us this new space. So our old lab was also a college space. It was excellent. It had a big pit full of sand that we could test our robot in. And this lab is actually even better. So we have this pit back here that's full of crushed limestone. It's encased with glass, and it is a perfect analog for the testing facilities that we're actually going to face when we go to competition. This is one of the only labs like this in the country, which is incredible for us to have as a resource.
It's also been part of the reason we were able to host the competition 2 years ago when NASA was not able to.
Yeah, if we had only had the old lab, we would not have been able to do that, because that pit was extremely small compared to this one and a lot more cramped, tight space, whereas this lab is much I wouldn't say larger, it's about the same
More
space
open.
really, but it's more open. And our old lab we shared with 2 other design teams. And this one we have all to ourselves. It's very nice.
Yeah, so we have a bank of computers back there that you can't see right now for our software team to kind of have their own little space. We have all of these big mechanical tables that you probably can't see because they're out of frame, but we built these tables ourselves. Previously, we only had room for 1, and now we have 4, which is incredible for the mechanical team. Trying to build a robot on 1 table is no fun.
We went from
on all of them right
we
now.
went from 1 to 4, and somehow we always managed to just have to fit all our stuff on 1 table, and immediately all 4 tables seem to be full of stuff.
Yes.
It's weird how that works.
It is weird how that works. You use the space that you're given, and we are so lucky to have this space. We also have a whole slew of tools and cabinets that are perfectly fitted for our team. We have a whole electrical station over there that you can't see right now. I'm sorry that you can't see more of it. I think online there is a virtual tour of our lab somewhere on the engineering website, probably.
Probably.
I'm not sure where that is.
There are also pictures out there. I can talk to Kat about posting some pictures of the lab.
There's already some on our Instagram, for example, and probably other social media too.
Yes. So definitely those are there. But yeah, so our lab is very nice. It's also card access, so we know everything will be safe and we feel safe leaving some of our very expensive equipment in here.
Yeah.
And yeah.
All right, we have some questions from the chat. Is there a performance metric or score consideration for robust or continued operation through either an onboard failure or perhaps extreme terrain or strata uncertainty? Tests AI navigation, control, and mechanical robustness. So I think that there are several aspects of the competition that deal with this. We get points for being dust tolerant. So as a result of the soil that we use, even just the limestone, it kind of aerosolizes and it creates this cloud of dust in the air. So that dust settles on every surface, not just in the pit too. Everything in the slab is covered in dust.
We have a vent hood that you can probably see a little bit of in the pit to get rid of some of that aerosolized dust so it doesn't get in. We also all wear respirators while in the pit to avoid breathing that in because that is not good for you.
But that kind of deals with the mechanical robustness of the system. For the software side, I'm not sure that there is a mechanic in the scoring for that, but we do several things for that. If you want to talk about that then.
So as part of the competition, obviously we have to navigate some obstacles, and that really plays into the autonomy side of things. The autonomy system is responsible for navigating around those obstacles. And obviously you can get a lot of points. Generally we get probably 10 or more times as many points from our autonomy system than we do from digging gravel. And so as a requirement for that, we're not allowed to touch the computer. And so if the robot does run into a situation where it has to navigate some complex terrain, obviously the software has to handle that properly and and if its first plan doesn't quite work out, it needs to replan, and it needs to be able to gracefully degrade as well. If we are unable to accomplish our top goal of full autonomy, we need to be able to recover from that, manually control to get out of whatever situation we were in, and then resume autonomy to get as many of the points for the lower categories that we can.
And that's especially true this year and last year because NASA increased the size of the obstacles to the point where the craters can be about as large as the robot itself. So we very much have to avoid those craters, otherwise we'll sink ourselves and be pretty much done for. So it's software autonomy is very much about the obstacle detection in the last couple of years because of those new obstacles.
Yes. So to answer the question about kind of the testing of robustness, there is not a scoring metric in that for the competition, but we do a lot of that ourselves. We do a lot of robustness testing.
Yeah. Also, the competition is comprised of 2 runs where your scores are added together, and that helps to ensure that the robot cannot just perform a one-off, that it needs to be able to repeat its success.
The obstacles get changed between each run. Between pretty much every team that runs, the obstacles get moved around, so a team can't watch a previous run and then go, okay, tell the robot to go in this exact path, because if they did that, they'd probably run into a new obstacle.
So we have some more questions. If any of you have had some internships, how has being on this team been helpful with those? So personally speaking, I interned at ULA over the summer, and I'm planning on going back next summer. In my interview, I talked almost solely about experiences that I had on this team. So the iteration that we do, the design, the problem solving, the teamwork, the leadership, all of that is helpful in building skills that you need for an internship and building experiences that you can talk about in your interviews. Does anybody else have?
Last summer, I interned at Caterpillar, and I would say the number one reason I got that internship was because of this team. That's how I met my contacts. Eric Reiners, if he's in the chat.
I don't think he's in.
Oh, well, anyway, he's who I met at the competition, and he kind of recruited me into Caterpillar, and yeah, so this team was a tremendous opportunity generator.
Yeah, so since our team has a reputation of success and of just really good people coming from it, the opportunity of being on the team in and of itself can get you connections and experiences and opportunities that you wouldn't otherwise get.
There have been companies that come straight, the engineering department brings to our lab because they're like, these people know what they're doing. You should ask them about internships. I was supposed to have an internship last summer, but I had to defer to next summer. But in that interview, most of what I talked about was Astrobotics. Is when someone asked you, what was a situation where something went wrong, you had to find another solution for it, my mind normally goes here because something happened on this team where I had to find another way to do it. So yeah, so it got me my internship. Sadly, did not get to do it.
That kind of leads into our next question. What was one of your most satisfying moments when you were building or testing the robots? Yeah.
I'd say after the second run,
Yeah.
if I wasn't back in the
Yeah.
If you go ahead.
Okay, so there's actually evidence of this. Like Dr. Phil Metzger posted a 2-minute video on his Twitter account. Like if you scroll far enough back, you probably can still find it. The last 2 minutes of our second competition run
In 2019.
In 2019, I believe that you already saw one part of that run, like the first half of that run. But the last 2 minutes of it, he was walking around in here watching us be extremely tense, worrying if our robot was going to work, because our previous competition run had not been so successful. We had some maintenance issues that had to be dealt with, and we were behind in the competition, and we needed a really good score to win. And in this run, we happened to get the 33 kilograms of gravel,
Which is a world record,
Which
by
is
the
a
way.
world record.
Not bragging.
And then you hear the countdown: 5, 4, 3, 2, 1, stop, and we all start celebrating.
Yeah. This was especially gratifying because the previous 48 hours we had worked basically around the clock, maintaining the robot, replacing parts, fixing problems, and the beginning of that run was so tense. We were all just waiting with bated breath to see if all of our work had paid off, and it had, which was a magical experience.
It was incredible.
Now imagine if you were watching this from 200 miles away, because you had to go home because you got the flu. And I was watching it just losing my mind because I was so far away and I couldn't see anything. Don't get the flu, kids. It's not fun.
Don't get the flu. All right, we have another question. Are international students allowed to participate? It's NASA competition, so I'm unsure. I don't know the answer to that question.
I would say you're allowed to be on our team. I'm not sure if you can be on our NASA roster because NASA does have very specific rules. I'm betting you could be on the roster.
I'm pretty sure if you're part of a U.S. university, you are allowed to be in the competition. The line is drawn where universities outside of the U.S. cannot.
Yeah.
I believe in 1 year NASA did expand the competition to have international teams. Like they don't do that anymore though.
But I'm betting if you are an international student who's at UA, yes, you could do everything that anyone else can do on their team.
Dr. Ricks answered the robustness question in the chat as well. A lot of the same things were said about the 2 competition runs. You can't just get lucky and have a Hail Mary run. And he explained that we put our robot through about 6 weeks of very rigorous testing before the competition. So we use it, we break it, we fix it, we break it again, we fix it again, and we try to solve every edge case that could ever happen to it.
Yeah.
So that is how we test.
We need bigger.
As we found out in our first competition run of the last competition, all it takes is one part on your robot that gets overlooked that has been running for a number of weeks to come a little bit out of alignment, and it can really wreak havoc. And so, yeah, it's very important.
Which is why we now have log sheets for what parts have been run for what amount of time.
Yes.
Yeah.
To stop that issue.
It's very important to keep track of how often you need to maintain your robot. How far apart are the competition runs? Days. Yeah, the competition itself is 5 days long. The first couple of days are practice runs, so you can practice in the competition pit. But the actual competition runs, I believe, occur across 3 days.
So at most, they can be 2 days apart.
Yeah.
Generally, it'd probably be about 1 day.
It depends on how the schedule goes, because especially when we're down at Kennedy Space Center, they have, let's say, constant inclement weather. So that can be a concern. Sometimes there are delays.
No,
It's indoors now.
Yes.
Like I'm speaking from the year when they were still outside. Yeah, they're indoors now, so that's probably less of a problem now.
But you have to do it with 50 different teams, each doing 2 runs. So you have about 100 runs you've got to schedule, and you don't want to put a team to have to do a run back to back, because that would be seen as unfair. So there's a lot of ways they got to go about that.
That being said, though, you do have to have everything that you need down there. So generally, it's going to be cost prohibitive for schools to bring down 2 robots, or just logistically impossible to bring, enough spare parts for absolutely every component that might break. And you do have limited space as well to work on your robot. So making sure that your robot will withstand all of the practice rounds and the 2 competition runs is very important.
Dr. Ricks has answered in the chat, yes, international students on U.S. university teams are allowed.
There we go.
We'd love to have you. Come on over. We have another question. How many universities compete?
Don't know.
So the answer to this question is typically 50. But this year, as many teams as possible were allowed to register for the first phase of the competition. And then the review gate at the end of this semester, so in December, we will find out if we've passed. The review gate serves as the down select to that 50 that usually competes in the competition. So it's more of a typical engineering proposal type schedule now. So
in the 2019 Caterpillar Robotic Mining Challenge.
yes,
That's
challenge.
Challenge, not competition. I believe 28 teams competed.
Yes. Yeah, that was the competition that was held here in our lab.
Yes.
And that was 26 or 28 teams showed up.
Fun fact,
28 teams registered and 26 came.
So fun fact, the last time I was in the basement of one of our engineering buildings, NERC, for those of you that know that building, that basement was where we housed all of the robots before competition. The last couple times I was there, the tape that we used to separate the arenas is still there.
Yes.
It has been almost a year and a half now since then.
So we had, to say a little bit more about this competition before we go, we had our work areas sectioned off in the basement of that building. We have a competition going in here. It was organized madness.
We also, at that point, still had access to our old lab, so we used the sand pit as a testing pit. And it was, so we were across pretty much the engineering side of campus, and we were just all across it. I was running a lot of the computer systems that were keeping video in different places. We realized if you run a bunch of Wi-Fi routers in a concrete box, you're going to have issues, which is basically what the basement of NERC is. So it was a lot of logistical fun for that weekend, for that week.
So we want to reiterate that we're definitely open to answering questions if you want to type them in the chat, or even if you want to just shout them out. We're open to answering questions. And I think we have about 10 minutes left before we end, and people might start dropping off to go to the next session. But
and I'm going to go ahead.
Love to have you. Thanks for showing up. Thanks for joining us for a good morning of robotics.
Yes. And if you have any other questions after this, feel free to contact us through the link on our website. There's a whole page for that. And feel free to follow us on all of these socials. I know
Please do. We post some pretty cool stuff. Our social media lead is constantly posting on Twitter and Instagram, so check us out. We got some cool stuff. She likes to post memes.
Yes.
We got more questions. Excellent. How do we join? So you join by expressing interest. So there's a contacting form on the website that says, hey, I'm interested in the team, and we will get in contact with you if you fill that out.
Yes, we will be having another, so we have 2 rounds where we admit people to the team. One at the beginning of the fall semester and one at the beginning of the spring semester. So don't be concerned if we don't get back to you for a little bit here at the end of the fall semester. That's just something we do to help manage the logistics so that we're not constantly monitoring a roster and trying to get people in the know when we're in the middle of trying to build something. So hang on tight, and at the beginning of the next semester,
we'd love to have you.
We normally have some kind of kickoff thing at the beginning of fall. I don't know if we're planning on doing one next semester. We may do one if we see that much kind of interest. So remains to be seen. But yes, do contact us. We will receive emails, and we will look at all of that, and we will welcome you next semester.
Yeah. We also have a question about where the lab is. We're located just off the quad. We're in one of the Bureau of Mines buildings. We're kind of hard to find, unfortunately. We're still working on our signage, but unfortunately, the lab is not open right now for visitors. But please contact us on our website if you have interest.
Yes.
Please do. We would love to just give you a tour, but unfortunately that is logistically impossible right now.
It's very sad. I never thought I'd miss people walking in and giving them tours, but I kind of do. It's nice to show off the lab.
It's nice to show off the lab. It's nice to introduce new people to our lab. So
now we just watch people walk by and look at our lab and watch as someone explain to what we are, but we can't say anything.
Yes, it's very unfortunate.
It's very sad.
Thank you to everyone who joined us. Thanks for everyone who's saying thanks in the chat, and we would love to talk with you guys later too. Yes, thank you so much to Liz Moore and the College of Engineering for allowing us to participate in Space Days. We love this week. It's so great to see all of the space industry come to campus and kind of see it come alive. This is what I live for, so.
We love space.
We love space here. Yes, thank you for everyone who showed up. Roll Tide.